Okay. Good morning, students. And this is Shivaj Patel. Welcome to Maths Chef YouTube channel, right? So, okay, this is the courtesy I have to follow for every class. Okay. The next chapter is chapter number 8 in for the CBSE 10th this year board exam. Introduction to Trigonometry. The wonderful chapter, and it is the fundamental. Okay, exactly it applies the before the maths and after the maths, right? So if you want to invent something else, it is the fundamental. If you want to study hard the history of the mathematics, it is important. So it is completely in the middle way. Okay, it occupies in the exactly middle. Means you can't leave the trigonometry in mathematics or in physics application, right? The most wonderful chapter. Okay, earlier as you are so lucky, you are getting the knowledge of trigonometry for this year. Okay, SSLC level. For us, it was for class 11th onwards. Okay, there it's not again the huge syllabus and competitive exams. It could not possible to understand the deep, the real depth of the trigonometry. Okay. Anyway, let's start this one. Chapter name is Introduction to Trigonometry. Introduction. Okay. Only you are learning introduction. Introduction is only basics of something. Introduction to trigonometry. Trigonometry. Right? Trigono means three angles. The shape with three sides. Three angles. Trigonometry means tri means what? Three. Okay. Gono means angle. Angles. And metry means measure or shape. Shape or measure. You can write also. Right? And the why the chapter is number 8 means it is the immediately after the triangles. That's basically similarity. Okay, even though they could have put in the first chapter something somewhere else, but deliberately, you see, your book is made by not a single person. Okay, it's a group of professors, highly qualified professors, scholars, even the scientists also. They have the lot of contribution to your curriculum. So because after the completion of the triangles, especially similar triangles, the Pythagoras theorem, they put the chapter number 8 is there for this stage. Okay, so we should have this some basics, means the should apply the basic skills we have learned in the triangles, especially similarity and Pythagoras theorem. Okay, so is the trigonometry, introduction to trigonometry. So before going to this introduction, let's start again. So go back to the triangles, similarity. Okay, so I have the rough work. This is the one big triangle. See, in application of the triangle similarity, you can see the height of the pole, height of the tree, height of the building, then the distance between something else. Right? You studied now the same thing in like that. Okay. You just imagine same thing here also, and see have the calculation sum 2, 4, 6, 8, and this is a 10 centimeter. Okay, one unit is 2 centimeters. Okay, I taken the perpendicular, this one perpendiculars, right? You can check on your home also. So okay, this I got 1.6, and this I got 3.2, and this I got 4.8, and this I got 2.6. All are centimeters, right? 2.7 and 2.5. Okay, here also you can have remembrance, but still I am telling you this one. This is the O, point A, point B, C, D, E, right? F, G, H, I, J. Okay, so you get the 1 pole, 2 pole, 3 pole, 4 pole. So this is the largest, which one? You can call the mountain. So we want to climb, we can't make the rope for this mountain. So we want supporting poles for this one. So here these colors consider these are the supporting poles. Pole 1, pole 2, pole 3, pole 4, like the mountain. Okay. Here we have the base distance. Okay. Base distance, base distance, base distance. Then we have this some rope. Okay. Length of the rope. Okay. Then you have to find C, not length of the rope. Then you have to have some pole distance corresponding heights, some different heights. You can take also 1.6 pole, 3.24, 4.8 pole, something else. Okay. Then you have to make the points on the rope, which is supporting point. Pivotal point you call na, exactly where the rope supports becomes a straight line. That is metal rope or steel rope you can make, right? Or bead also. See, here the what the beauty is here. Okay. See with respect to over. Okay. This is over. Right. See, in our similarity, what I have learnt is, sorry, it makes some noise. Right. In similarity, what I have learnt, the triangles are similar. Okay. Consider triangle, which one? O, F, A, and triangle O, G, B. Right? O, F, A. This O, F, A and O, G, B. Right? Triangle. Right. Okay. O, F, A. Right? So, angle O is common. Angle O is common. Writing as a common angle. And angle A is equal to angle B is equal to 90 degree given. Therefore, by AA similarity, okay, just the basics of the your similarity principle. Similarity, triangle OFA is congruent to triangle OGB. Right? If the triangles are similar, then we have the formula, right? Then you can write, okay, OG by OF, right? Corresponding parts in proportion, and GB by next FA and OB by OA. Very important. This is the thing here, right? Got it, na? Like let's see here. Or the ratio. So we already proved. We no need to prove the things here. You can put the here. What the OZ? See here. What the OZ here? What the OZ is? See 2.6, 2.7, 2.5, 2.6, 2.7, 5.3, 5.3 by what the OF is 2.6 is equal to or GB 3.2. For the FA 1.6, what is OB is 4, what is OA? OA is 2. So we are getting nearly 2.6 na, 2.6 then 2 to 5.2, 2 is equal to 2, 1.6 equal to 2. See, we are getting the same ratio. This means ratios are constant, right? This is the thing here. Just I am doing some modifications in this equation. Okay, OZ by OF is there na, GB by, okay, I will take this one. Okay, OZ by OF is equal to GB by FA. Okay, see, before inventing discovering the trigonometry, okay, the mathematician, the scientist have a lot of struggle in making the triangle because have to make the triangles, have to make the triangles. But after inventing the triangles, trigonometry, the mathematics, the physics application becomes very easy, right? So next coming class, time, you came to know. Okay, see, if you want to define distance something else, again, see, you have to measure the angle here. Okay, I have to see different sides, different angles. I take the hefty calculation, carry. So in math, okay, in paperwork it is easy, but you want to in the real life, if you want to cut exactly, that is very difficult now. So, but after the trigonometry, so just making the angle is very important. Okay, if you put the angle, automatically all sides, all ropes ropes points and pole points and distance will get easily, very easily with the standard angles, right? OZ by OF, okay, just a cross multiplication, right? What I am doing is FA by OF, right, is equal to OF, right, that GB by OZ, right, GB by OZ, right. Okay, what is FA here? Point is, what is FA here? FA is 1.6 and what is OF here? OF is 2.6 is equal to the GB here 3.2 and what is OZ here 5.3. So this I made the calculation. We are getting the value 2.6. I am getting the value 2.6, 1.6, 0.6, right? You can check the value 0.6 equal to 0.6, same value, right? So this is, okay, this is exactly makes a 38 degree. This ratio exactly makes a 38 degree here. This value means if you divide the GB by OZ, right, GB by OZ or FA by OF, FA by OF, you will get the degree exactly 38 degree. Okay, exact 38 degree. But that is the beauty here. Okay, this what I am writing as, this is the FA by OF is equal to GB by OZ. We are writing as sine of 38 degree. Sine of 38 degree. 38 degree. See, if you know the things already, you can go home and check the Casio range. What the value of sine 38 degree is? 1.6. Something else, build the rational number. Give some digits also. But beginning is 0.6. Similarly, for this one, which one? Take the GB by OB, right? Okay, I am erasing this one. Okay, for this angle, okay, for this, which one? GB by OB, GB by FA is equal to OB by OA. Okay, this ratio, just do the cross multiplication, right? GB by, okay, GB by OB, right? This one means I have to make here OB by GB, okay? OA by FA is equal to and OB by GB, right? OB by GB we got, na? GB by, okay, not this one. OA by OF, FA, not this one, okay, should not take this one, okay, should take the ZB by, not ZB, you should take OZ by OB, right, OZ by OF is equal to OB by OA, right. This again do the cross multiplication. OB by, let's keep it is OA by OF is equal to OB by OG. What is the OA here? 2. What is the OF here? 2.6. What is OB here? 4. What is the OG here? 5.3. Still we are getting the value. What the curve is? Okay. 7.75. Okay. 7.5. 0.75. 0.75 is equal to 0.75, right? This is cos 41 degree. So you can go home and check the value also. right? Cos 41 degree. It here also. See, if you want to take, see, this is called, and this is called sine of angle. This is called sine of angle. This is called cosine of angle. Cosine of angle. Right? So I am getting things here. Sine of angle and cosine of angle. Okay. This is, we are going to, which one? Define the terms, ratios. Okay. See here also, with respect to sine it is 38, with respect to cos it is 41, right? This is okay. Right? Then see what the difference here. Okay. What is OA by OF? OA by OF here. What is OA by OF? Can I write this as base by hypotenuse. See, this is the base. This is the base. This is the hypotenuse H. This is the opposite or perpendicular. Okay. Similarly, OB by OF. Right? What is the OB here? OB by OG. Right? OB by OG. OB by OG is equal to base by H, hypotenuse. C here. What the sine is? What the FA by OF is? What is FA? Perpendicular. P by, what is the OF is? Hypotenuse. Again P by hypotenuse. We are getting sine 38 degree. Okay. The 48 and 38 are equal, right? Okay. The different values. Okay. If you taken this value, okay, you should get the C. 38 and 48 are not further distance, okay, because now it has this 7 digit. 0.6 not a value. 0.6 has a 6 to 7 digits, and 0.5 is a 6 to 7 digits. That's the variation of this one. Okay. Here you should get the value. See why I make this scale here. 2 units, 2 units, 2 units, 2 units, and draw the perpendicular. This one, and I measure the length here. Here, and note it. Okay. That's why I getting some errors here, because now this is the 6 to 7 digits decimal expansion. This also 7 to 8 is decimal expansion. That is the 3 degree errors, because now here should also get 0.6, here should also 0.6. Those exact sine 45 you get. If you are taking the sine 45, you will get the same values. Means 45 degree make exactly 45 degree. Okay, because now I do not have the compass. Okay, that's the problem. So instead of wasting the time, so I started the teaching, right? Taking the example. If I got the compass now, I will again set the exact values. This value. Even though next video I will pakka, I will show you, right? Okay, this is the sine of angle. This is the cosine of angle. So this is the cosine of angle. You are making angle na here 30 degree. Let's make it a 40 degree. Okay, for sine 45 also, for sine 38 average angle. For cos 41 and sine 38 40 degrees average angle. Okay, this is the cos of OB by OH. OB by OG base by hypotenuse is cosine of angle, and base by which one? Perpendicular by hypotenuse. Perpendicular hypotenuse is sine of angle. Okay, this is the very basics. Okay, right. I told you na. Again, see, either the application is maybe a parachute of height, second parachute, mountain, Rassi, bridge, okay, slope, flight movement, right? And then ship movement also we can take. With make angle with respect to one way, in the sin, so it will move circular way. But there also you can find the only thing is here, the ratio between the base to the hypotenuse is called cosine, and the ratio between the perpendicular to the hypotenuse is called sine of the angle. First angle is sine of the angle, and this is the completely this sine, which one? Indian constitution. Okay, Brahmagupta, I think so. Right? Aryabhatta, he was the first person to use this ratio, because even though they used in the trigonometrical ratio, similarity, trigonometrical ratio, but this sine, cos and tan, they given by the Western mathematicians, okay, because they have the beauty, the Greek words, they are beautiful words. That's why still we are using the in mathematical symbols, all Greek symbols, right? That's why once again I will explain here. It's about this triangle. Okay, see, trigonometry has a different application, different than the perception. Application or perception, it has a use of potential, means we use open topic. So whether you can apply, you can apply the biology, zoology, each one, then where physics, chemistry, okay, and statics, okay, probability, wherever you see, there is the pattern again, depends on the lines, okay. In the first ICIC, you study as a circular function, because the wherever you can make a right angle triangle, wherever it is, where is the place, okay, in graphical notation, wherever you can make the right angle triangle, there you can use have the complete liberty of using the trigonometric ratios. Okay, let's take the standard angles, right? Right angle triangle. This is A, this is B, this is C, right? This is actually angle A, but I am taking the angle theta. Okay, theta is the space made by the two line segment with a common vertex, right? Or the angle is space made by the two line segment AB and AC with a common vertex. Common vertex is A, right? So sine of angle is called, this is called base, and this is the called perpendicular, right? Or they given in book, some books, okay. Side also is looking right, hypotenuse, opposite or right. Okay. Side opposite, side adjacent, right? So perpendicular, because this is 90 degree, okay. Perpendicular also you can call. In ICS they given like that, also called opposite. Okay, but here they give this is side, right? Adjacent to the angle, adjacent to the angle. Here, this is definition is side, because now this is the theta, this becomes the adjacent, and this becomes the opposite, right? This becomes opposite, side opposite to the angle, opposite to the angle, right? Any right angle triangle, wherever in circle also you can make the right angle. This should be considered. If you are taking this as theta, then this becomes okay. You write also here. Make the right angle triangle, wherever it may be, right? Yes. A, B, C. If I am making theta here, again, this is the 90 degree, okay. This is hypotenuse. This is also, yes, hypotenuse, okay. See, this is the theta, okay. With respect to this is the base, this is opposite, okay. In book, according to book, this is written as side, because this is the theta, side adjacent adjacent to the angle. This is side opposite to the angle. Right? Based on these definitions, you have the 6 different angles, ratios, not angles, ratios. Right? Based on these definitions, base, perpendicular, opposite, base or opposite, side adjacent to the angle, right? Side adjacent to the angle or side opposite to the angle. Based on this, you have 6 trigonometric ratios. 6 trigonometric ratios, right? Let's study one by one. In 6, we have divided the 3 are standards and remaining 3 are reciprocal ratios. Standard ratios and reciprocal ratios, right? First study the standard ratios. Right? First one is sine of angle. Sine of angle written as sine theta, because the theta is reference. You can take A, B, C, N, M, N, X, Y, whatever it may be. If you taken the given theta, I am taking. If not given, take the point A, angle B, angle C, angle A, angle B, like that, right? Theta. Definition is, okay, ratio of side opposite to the angle to the hypotenuse. Hypotenuse, right? Hypotenuse. This is on the side here. Opposite is BC by AC, right? Sin theta. Okay, this is, you can write also perpendicular by H or opposite by H. Okay, you can write also this is O by H. O means opposite. For the sine of the angle is sin theta. Side opposite to the angle divided by the hypotenuse. The ratio of the opposite side to the hypotenuse is called sine of the angle or sin theta. Similarly, cosine theta, cosine of angle is referred as, cosine of angle is referred as, okay, side adjacent to angle, to the angle also, divided by hypotenuse. Hypotenuse written as cos theta. Okay, see, this is not sin theta, it is a sin theta. Sine word, sin, not a sin, sin theta, right? This is equal to, what is adjacent here? AB by AC. What is also called base by H, also called adjacent. A by, not H, base, opposite base only. Okay. Adjacent, I can call also adjacent by H, capital H, right, for cos theta. Another one is for standard angles, standard ratios. Okay, standard ratios 1, 2, 3. Okay, third one is tangent of theta, tangent of angle. Okay, referred as tan theta is equal to, okay, opposite side. Okay, I am writing this angle, so side opposite to the angle means opposite side divided by which one? adjacent side. Adjacent. Okay. What is the opposite here? Tan theta is equal to BC by AB. What is BC? Perpendicular by A or opposite by A. Okay. These are the three standard angles: sin theta, cos theta, tan theta. What is sin theta? Is perpendicular by hypotenuse, and side opposite to the angle by hypotenuse. Cos theta is side adjacent to the angle divided by hypotenuse, means base by hypotenuse. So tan theta, side opposite to the angle divided by side adjacent to the angle, is called tan theta, right? Next, okay, here only some reciprocal ratios or reciprocal angles we can call. Standard angles or reciprocal angles. Okay, reciprocal ratios. Reciprocal can call also. Okay, this is how defined as. The reciprocal means okay, reciprocal of sin, reciprocal of cos, reciprocal of tan. Okay, reciprocal of sin, reciprocal of cos. Okay, first one is cosecant theta, right? Secant theta, secant of angle, written as, right, sec theta. Okay, secant of angle are equal to secant theta or sec theta. Secant theta or sec theta. What is the here? Hypotenuse by base. Right? Hypotenuse by angle adjacent to the which one? Angle side of adjacent to the angle base. Adjacent or base you can call also. Adjacent you can write here. A. See what cos theta we have? Cos theta we have A by H, right? Therefore, sin theta we can write, sec theta we can write, sec theta we can write. Okay, this can write as 1 by A by H. This is 1 by cos theta, right? Sec theta is equal to 1 by cos theta. This we can write H by S, A by H, right? Similarly, cosecant theta we have. Second one is cosecant theta. Cosecant of angle or cosec theta. Cosec theta is opposite of hyposine. H by P means H by P here. So if you want to write this one, AC by AB. Okay, consider this one also. AC by AB. Right? Cosec theta is, what is H here? AC by BC. So this can write as cosec theta. Cosecant theta I can write as 1 by H by P. What is H by P? Okay, 1 by P by H. P by H I write as 1 by sin theta. Therefore, cosecant theta is equal to 1 by sin theta. That's why I call reciprocal angles. Okay, only three. If you know the three angles, that's enough. So second angles you can, by some examples you come to know the topics. Okay, secant theta is the reciprocal of hypotenuse by adjacent. Cosecant theta is hypotenuse by perpendicular, opposite to sine, opposite to the cos. 1 by sine, 1 by cos, right? Another one is that cotangent theta. Cotangent theta, cotangent of angle. Cotangent of angle, written as cot theta. Cot theta is equal to, okay, reverse of, okay, base by perpendicular. What is the base here? AB by BC, right? this can write as cot theta can write as 1 by p by b can write 1 by tan theta or p by b tan theta. Therefore cot theta is equal to 1 by tan theta. Guys, these are the standard ratios, trigonometric ratios, right? So here I have to define again, or tan theta is P by AC. The time here. Okay, tan theta is here. See here also. What tan theta we have? Tan theta is we have AB by AC, na? B by P, right? This can write as, okay, B by B, na? P by B. P by B means perpendicular by base. This can write as D by H and B by H. What is P by H here? What is the sin theta? Okay. P by H here, sin theta, na? This can write as sin theta by cos theta. Right? Similarly, for cot and theta, we have cot means cos theta, then we can write by sin theta. For cot we have cos theta by sin theta. For tan we have sin theta by cos theta. Right? Okay. Once again, the repetition. First, in trigonometry there are 6 angles, 6 ratios. Instead of called angles, 6 ratios. First three is called standard ratios and remaining 3 is called reciprocal ratios. First 3 are sine, cosine and tangent. Sine is opposite by the side opposite to the angle by hypotenuse, or the cos is the side adjacent to the angle to the hypotenuse, and tan is opposite by the adjacent. Similarly for the reciprocal angles, second theta is base by hypotenuse, the angle side adjacent to the angle divided by hypotenuse. For cosecant is opposite of sine, okay, hypotenuse by perpendicular. Cotangent, tangent is base by perpendicular, opposite to the tan. Okay. Also tan theta you can write the sin theta by cos theta. For cot theta you have cos theta by sin theta. These are the reciprocal angles. Okay. Just by solving the examples, you can solve the remaining. First, if you are getting the only one angle, you can find the remaining ratios of the other angles also. Trigonometric ratio, right? Let's take the example. First one is, right, given question number 1, given that tan A is equal to 4 by 3, find the other trigonometric ratio. Find the other trigonometric ratio. See, whether or not the angle, the trigonometric angles are the ratio of the two sides. Okay, base by hypotenuse, perpendicular by hypotenuse, hypotenuse by base, base by perpendicular, perpendicular by base, like that. All 6 angles are the ratios, they are not the standard values. This is something else. Okay, so they given tan A is equal to 4 by 3. First make the right angle triangle here. Simple solution. Okay, right angle triangle, right? This is A, this is B, this is C. Tan A na should take this one, right? They given A, this is the angle. They given theta, you can take this one, but one angle should be right angle, 90 degree, compulsory, right? Because how to use because you proved the trigonometry only right angle triangle, not in a similar to right triangle, not in a normal triangles, right? What the tan A is equal to here? What the definition is with respect to tan A is equal to perpendicular by, right, side, right, opposite to the angle, opposite by hypotenuse by base na side adjacent to the angle. What is the opposite here? BC. What is the base here? AC. Therefore, tan A is equal to BC by AC here. Therefore, what they given here? Tan A is equal to BC by AC is equal to 4 by 3. They given, right? 4 by 3. So this BC becomes 4 and AC becomes 3. Right? Using Pythagoras theorem, you can find this angle. Na? What the AB square is? What is AB is? Square root of BC square plus AC square. Right? What is the BC square here? 4 square plus 3 square. 4 square is 16, 3 square is 9. Square root of 16 plus 9 is 25. We are getting the value 5. Therefore, AB is 5. Right? AB is 5. Then find the remaining values. We got the 3 ratios. We have the 3 values of the triangle, all sides. Only thing is have to find the remaining ratio. Right? First one is sin A. Right? So means remaining ratio means with respect to only this angle only, not B, not C. Right? Sin A, cos A, tan A, cot A, secant A, cosecant A, like that. Right? Sin A. Regulating. Okay. What is the definition? Opposite by hypotenuse. Hypo. What is opposite here? BC. BC by what is the hypo here? AB. Therefore, what is the value here? BC is 4 by 5. Therefore, sin A is equal to 4 by 5. Second one, right? First one. Cos A. Cos A is definition adjacent, right? Adjacent. Adjacent by hypo. What is the adjacent here? AC. What is the hypo here? AB. What is the AC? 3. What is the AB? 5. Therefore, cos A is equal to 3 by 5. Then 3 angles are done, standard angles. Then reciprocal angles. Fourth one, the third one. Okay. Third one is secant A. Sec A. Opposite of sin. Second is reciprocal of sin. See, here you can write the things only, or you can write the 1 by cos A definition. What the 1 by cos A? 1 by 3 by 5 becomes 5 by 3. Therefore, both are correct. 5 by 3. You can use the definition also. What the definition is saying? Hypotenuse by base, na? Hypotenuse by base, 5 by 3. Then fourth one is cosec A. Cosec A is equal to 1 by sin A. Okay, what is 1 by sin A is 1 by 4 by 5. This is like that, right? This becomes 5 by 4. Therefore, cosec of A is 5 by 4. Last one is cot A. Cot A is 1 by tan A. What is 1 by tan A is what? A given already. Okay. 1 by 4 by 3. 4 by 3. Therefore, cot A is equal to 3 by 4. Fifth one. Right? Have done the 6 angles, right? Similarly, same question they are asking here. Okay. Okay. In next class, we will solve some examples, solved examples and exercise examples, and we'll continue with the next class. Okay. And okay. Thanks for watching. Bye.